So the title of this chapter, Roots, or of this lesson, Roots of Real Numbers, and this entire chapter is going to deal with roots and radicals. To come to the office, should be leaving for the day. When you look at this symbol, Stuart Hansen to the office, she'll be leaving for the day. This is not called the check mark thingy. This is called a radical. Okay? This is called a radical. And radical sign for short. Whatever is underneath is what is called the radicand. Okay, that's the number that you're going to be rooting, or whatever the object is. If I don't have anything written here, it's assumed you're looking for a square root, right? So square root of 4 is 2. Okay? But if anything is written here, in this spot, this is called the index. Okay, anytime something is written in that little spot, it changes the fact that you're doing the square root, which is the norm, which is what you're used to doing, okay? Trying to think. Yeah, so if I asked you for this, I'm not asking for the square root, I'm asking for the cube root, okay, which you would be able to find out is 64. Your calculators will be able to do a lot of this for you. Every calculator does it a little bit differently though, so I'm not certain I would know how to do yours. I'd be happy to try if you need to, but more often than not, if you kind of peck around and look at stuff that kind of looks like it might be a root, you should be able to figure it out, okay? Mine actually has a little, a radical sign, and then I just put whatever's underneath, but I don't know if I can change my index. Oh, I can do a cube root on mine too. I might be able to change it. I don't know. So all calculators are a little bit different, okay? So obviously a square root is the number, a number, times itself gives us an amount, okay? The square root of that amount is whatever the number is that we multiplied by itself, okay? Square root of 16, 4. Square root of 64, 8. All that stuff you've learned eons ago. Those are square roots, okay? Now, normally, you're going to say to me the square root of 16 is 4. It's the principal square root. It's what you would normally answer it with, okay? The positive square root. That's what you're going to tell me, okay? You could also say negative 4, right? Or negative 8, because negative 8 times negative 8 does give you that positive, right? But for most purposes, you're really going to be looking for that positive square root. Now, if it says find the roots, you are going to want to find both, okay, which we'll get to that here in a second. So, example 1. It simply says simplify, okay? Simplify. And for A, they give you the square root of 9. You are simply going to say 3. You're not going to say 3 and negative 3 in this case because they're saying keep it simple. Give me the simple answer. Okay? Put simply the square root of 9 is 3. And B says the opposite of the square root of 9. Okay? So if the square root of 9 is 3, its opposite is negative 3. All right? And C, the square root of 1 over 9, what number times itself will give us 1/9? You should have came up with 1/3 there. Okay? It's that simple. The square root of 9/100, this is D. Square root of 9/100 is going to be 3/10. Okay? Some of these might come to you, some of these might not. But in any case, you're going to have opportunities to simplify. Okay? Now, keep in mind that any real number squared is always going to be a positive result. Okay? Always, always, always going to be a positive result. Okay? That's in the real number world. Okay? If I tell you -16 up here, then I am no longer in the land of real numbers. I enter the land of irrational numbers, which we will enter later. All right? Example 2. Example 2. So this is one of those examples where I want you to keep in mind it says find the roots, S being plural. This is where you're going to have to give not only the principal square root, which is the positive that you think of naturally, but the negative. Okay? Something like this, for example. X squared is 9. So to solve, you're going to want to find what the square root is. Okay? X equals the square root of 9. Okay? I just took this and said, well, I need to find the square root of this so that I could find the square root of that. The square root of x squared is x. The square root of 9, since it tells me is roots, it wants both of these solutions. Whenever you see a plural, assume they want both. Okay? Whereas in contrast, x squared plus 4 equals 0. Solve it a little further. X squared equals -4. Remember what I just said to you a couple minutes ago? There is not going to be a real number solution for that. There will be later. It won't be a real number, though. You're going to tell me that there are none or no real roots. Okay, because there aren't any. We're looking for real roots, real numbers, not irrational numbers. Okay, we're going to talk about those in the future. Moving on. Example C. You might have to do a little manipulating in the math. All right. 5x squared is 15. Let's divide by that coefficient, 5, and we should have x squared equaling 3. Now, is that a perfect square? No. So now, you're going to not really be able to get from here to here, but you will be able to answer it by saying x is equivalent to the positive or negative square root of 3, since it's not a perfect square. Okay? That is the best answer you can give me. You cannot go any further than that. Okay, I don't want you to give me the 1.2967482, whatever the number is. All right? Okay. All right. Let's head over to example 3, where we work with cube roots. So we're working on cube roots. This is when the index is a 3. Okay, that should be floating up a little higher. I don't want it to look like it's a regular 3. Sorry about that. Okay? So these might require you to be a little bit intuitive. Let's look at A for a minute real quick. The cube root of 8. 2 times 2 is 4 times 2 is 8. Okay? We are simply simplifying here, so all I have to give is the normal one. Okay? The principal square root as it is. Okay? B, you're going to look at this and say, Mrs. Myers, you just told me negative numbers don't have a square root. You're right, but they can have a cube root. Okay? They can have a cube root, right? 3 times 3 is 9 times 3 is 27. That would be the positive. But if I take -3 and I cube it, I do get -27. Therefore, the cube root or odd indexed roots can be a negative. Okay? Cube roots can be a negative. Okay, C. Now they're getting a little crazy. C. The cube root of 10 to the 6th. Okay, So if I say 10, 2, 10, 2, 10, 2, that's how I get 10 to the 6th, right? Which would mean the cube root of this would be 10 squared. Okay, that's where you're going to come up with 100. Okay? Last one in this group, letter D. Similar to that one, cube root of A9. Remember, it's exponents, so you're thinking 3 times 3 is 9 times 3 is 27. No, exponents you add when you're dealing with roots and squaring or powers. A to the 3rd is going to be your answer there. Okay? Example 4. This is the one where it's awful, and you're really going to want to hopefully find a way to solve those on your calculator. I never ever get bound up in these. I usually don't have you do too many of those harder ones because I don't think there's much of a point. But for sake of argument, I'm going to show it to you. 4th root of 81. We've moved on to example 4. And all they're saying is simplify here, so you don't have to give me positive and negative roots. 3 times 3 is 9, times 3 is 27, times 3 is 81. The answer is 3. If your calculator allows you to do that, you might be able to plug in. Yeah, mine doesn't. I thought mine did, but it doesn't. Anyway, maybe yours does. 5th root of 32. What number times itself 5 times? So, B, the 5th root of 32. 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32. Okay? Remember I said be patient. It's not going to be intuitive. You're going to have to think. You're going to have to test. 5th root of negative 32. Do you guys remember how I said odd indices can have a negative root? Well, since the 5th root of 32 is 2, then the 5th root of negative 32 is going to be negative 2. Okay? When you multiply that 2 to the 5th power, since it's negative, it'll give you a negative 32. Okay? But, in contrast, D, we're back to an even root, like square roots. The 6th root of negative 1, there is none. Because when your index is even, you can't have a negative a negative item have a real root. Okay? There is no real root there. Alright, take a gander at that thing on page 261, the little gray box there. On the left, it describes properties of radicals using algebraic words, but the examples make it a whole lot clearer. And I just want to show you something that you're going to actually use as part of number 1. This, the square root of anything squared is going to give you the item underneath. Okay? So if I take the square root of 8, which is not a normal number, and I square it, I get the 8. Okay? Look at it with a number that would work. The square root of 4 is 4. Well, what's the square root of 4? 2. If I square it, I indeed do get that 4. This little nugget of knowledge is going to come so in handy for you later this year. Same with if you find the cube roots or the 5th roots, as long as the exponent matches, it's just going to be that item. That's example 2. You could look at 3. We're not really going to get into 3 just yet. For today, I have you only doing 12 problems. That's because for each problem in 2 through 14, you have multiple items.